Hey students, this is Mr. Roberts back with you to go over 7.2a, solving equations with addition and subtraction. Now, yesterday we talked about writing equations by, we gave you word sentences and we turned those word sentences into equations. Now we are going to actually be solving equations that deal with addition and subtraction. And that, if you look here at this little cheat sheet that I have, we're looking at this and this. So these two boxes right here. And I'm going to go over this and show you exactly what we're doing and then refer back to this card so you can kind of make the connection. So let's get into your Bellwork. All right, so let's take a look at number 1. Number 1 says, identify if the question is statistical or non-statistical. How much time do 6th grade students typically spend on homework each night? Now, remember back to when we talked about statistical questions, that the answer has to have a varied amount of responses. If I ask this question to a class of students, would I get 1 or 2 answers or could I get multiple answers? If you say yes to the multiple answers, you know that this would be a statistical question. So yeah, we want to say this is a statistical question. Let's take a look at number 2. Okay, so number 2 is kind of a rough question, and I'm kind of debating on how I want to do this. I think we're just going to do this one in class. So I'm going to skip this one for right now, and we'll come back to it maybe later. But let's just go on to number 3 now. Barnes Bookstore was selling 4 books for $21.80, and a website was selling 6 books for $32.16. Which place has the lower unit price? So this is how again, this is just a unit rate. So we're paying $21.80 for 4 books at this place. And we're paying $32.16 for 6 books. And we want to see which one per book is the better deal. So $21.80 divided by 4, we get $5.45 at this place, that store. Online, we're going to go $32.16 divided by 6. And we get $5.36. So the online price is the better deal. All right, there's your Bellwork. Let's move on to some notes. Okay, so we're going to start introducing you to solving one-step equations today. And we use something called railroad tracks. And you can see that there at the top of the page. I'm going to highlight that because it is an important thing. So I'm just going to turn this green so we emphasize that when we talk about railroad tracks, we're talking about solving equations. So the first thing that we need to kind of analyze here is what inverse operations are. And inverse operations are, well, if I'm multiplying, the inverse operation is division. And if I'm given multiplication, to undo it, I divide. If I'm given division, to undo it, I multiply. If I'm given addition, I use subtraction to undo it. And if I'm given subtraction, I use addition to undo it. So the steps for this, and so just write down the things I'm writing down for now, and then you'll see how it applies in a moment. So draw railroad tracks, recognize and isolate the variable, identify the inverse operation, apply it to both sides of the equal sign. Then you solve, box the solution, check your solution, rewrite the original equation, use substitution to check. And so we're going to show you how to do this. I'm going to just do the addition and these addition and subtraction ones. That's what we're focusing on for the next 2 days. So if we're going through that checklist, the first thing it says, find the equal sign, and draw a railroad track. So that's what I'm going to do. There's my railroad track. Then it says, recognize and isolate the variable. Okay, so we know that we have a variable right here. X plus 6. There's my variable. We want it to be by itself. The way that I teach this, guys, is that variable is unlike the regular numbers. It's different. It wants the other numbers to go to be with other numbers just like them. And the variable wants to be by itself because it's a variable. It's different. So this is what happens. So it says use the inverse operation. So we have this x plus 6 here. Here's the variable. We want it to be by itself. What is the inverse of this? It's minus 6. Because I subtracted 6, there's nothing there now except for the x. And here's the thing that you have to understand about equations. If I do something to one side of the equation, like I subtracted 6 here, I have to subtract 6 here. So I'm going to subtract 6 here, and I get 5. So I'm left with x equals 5. Put a box around it. Now let's check. I'm going to take this 5 and put it back into the original equation. What is 5 plus 6? Oh, it's 11. I did it right. So that's how you can check to see if you get it correct, is use substitution. You substitute that number back in. All right, let's try one with subtraction now. All right, here's my railroad track. There, my variable is right here with the y minus 3. The y wants to be by itself, so we have to get this 3 to go away. So we use inverse operation to do that. We are going to add 3. Negative 3 plus 3, there is nothing left there except for the variable. Bring down my equal sign. And because I added 3 here, I'm going to add 3 here, and I am left with 13. Put a box around it. Take your 13, put it back up in for y. So this 13 comes back up here. We're substituting it. 13 minus 3 is 10. We did it right. That's really all there is to this. So let's try some of these out on your practice. All right, the way that I want to do this practice today is I am going to do one, and then I want you to do the other one. So I'm going to do all the odds, and you're going to be doing the evens one by one as we go through. So first thing I'm going to do is I am going to go draw my railroad track, isolate the variable. I'm going to minus 7. That's gone now. Left with x. Minus 7 here. We get 3. Put a box around your answer. 3 plus 7. I plug it back into where the x is. I got it correct. All right. I want you to do number 2 on your own. When you're done, unpause the video. All right. Did you get y equals 8? If you did it correct. All right, let's move on to number 3. All right, I am going to start out by drawing a railroad track at my equal sign. Now, you're going to see that the variable's on the other side of the equation, but it doesn't change anything. We're going to do the same thing. We're going to add 9 here. We're left with the b. We're going to add 9 here. We get 13. Let's plug that 13 back in for b. 13 minus 9, is it 4? Yep, we did it correct. All right, let's have you try number 4. There it is. I want you to try number 4, and so hit pause, and when you're done with it, unpause the video. All right, did you get z equals 24? That is the answer. If you got that, you're doing a good job. Let's move on to number 5 now. Number 5 says a minus 12 equals 16. There is my railroad track. I'm going to add 12, doing the inverse operation, remember. I'm sorry, 12. Goodbye. Left with an A. We get plus 13 here, or 12. I don't know why I keep on saying 13. So we get 8, we get 28. So is 28 minus 12 16? It sure is. So we did that one correct. Let's have you try number 6 on your own. Okay, did you get 16 equals C? If you did it correctly. Moving on to number 7. Number 7, here we go. Draw your railroad tracks. We are going to minus 4 from both sides of this equation. We're left with x here, minus 4. So we are left with 8. X equals 8. Is 8 plus 4 12? It is, so we did it correctly. Your turn. Let's do number 8. Ooh, this one has decimals. Don't forget when you're doing this, you can use a calculator, but if you're not using a calculator, you can just line the decimals up. Remember, when we add and subtract decimals, we line them up. So we'll see if you get the same thing I do. Here you go, your turn. All right, did you get D equals 9.6? If you did it correct. Let's move on. All right, here's one with a decimal for me to do. Here it is. There's my wall, or my railroad track, sorry. I'm going to get the variable by itself by using the inverse operation. So I'm going to subtract 23 3/10 away, and I'm left with F here. And because I subtracted on that side, I have to do the same on this side. So 23 3/10. I'm going to pull out my calculator. 45 1/10 minus 23 3/10, and we get 21 8/10. That is the correct answer, because if I plug it in there, 21 8/10 plus 23 3/10 is 45 1/10. All right, let's move on to the last one on this page. It is for you to do. Here you go. Give this one a try. All right, if you got 4 equals U, you did it correct. Now, something to point out here, guys, is that it doesn't matter if you flip-flop these. And I mean, 4 equals U and U equals 4 are exactly the same thing. So it doesn't matter if those are flip-flopped. I know that I kind of had some problems with that when I was your age. I was like, wait a second, that variable's on the right-hand side, so it looks kind of weird. Well, don't be confused. If you don't like the way that this looks, just flip it. It's the same answer. So, all right, let's look at your assignment now. All right, so I'm sitting here, I'm looking at your assignment. We're looking at these questions. It looks like there isn't anything that wasn't on the practice. So if you looked at the practice, the assignment's going to be very easy. There are some problems down here that are a little bit different. And it kind of puts what we did in yesterday's assignment and today's assignment. It kind of merges them and does them together. So I am going to do number 10 here. And you can see that it wants us to write an equation and then give a solution. So we're going to write an equation here from the words. And it's an important skill that you have to be able to do this. So 13 subtracted from a number. So wait, what comes first? The 13 or the number? Because it says 13 is being subtracted from a number. So we have a number that's called W, and it's first. So W minus 13 is 15. Okay, now I need to solve it. Add 13 to both sides. That disappears, becomes W here. Because I did the add 13 on one side, I have to do it on the other. I get 28. Is 28 minus 13 15? It certainly is. There's our solution. So that's all there really is to this, is that you have to be able to write these equations from the words and then solve them. So I think from here on out, you can do that. If there are questions that you have, as always, ask your teacher. We'd be glad to help you. All right, guys, good luck on this, and we'll talk to you in a few minutes.